This is blog post number 3, and I will go over on why is a normal tangent graph uphill but a normal cotangent graph downhill. Okay, so as we can see right here, we have our tangent graph going uphill while our cotangent graph is going downhill. And there are two major reasons why this happens. And one is due to the difference of the isotopes of tan and cotangent, and also it's due to the quadrants of ASTC, and where tangent and cotangent are equal to positive or negative. And so first let's go over our quadrants. So we have ASTC, and we know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, and we know that at quadrant 1, both tangent and cotangent are positive. In quadrant 2, we know that they are negative. In quadrant 3, they are positive. And then quadrant 4, they are negative again. So, knowing that, we also have to know about the isotopes. Okay, so going back to unit Q and our identities, we know that tangent of theta is the same as sine of theta over cosine of theta. So meaning that our isotopes would be located wherever cosine, meaning x, is equal to 0. So that way we would have 1 over 0, which gives us undefined. And that only happens at 90 degrees and at 270 degrees, where we have the ordered pair of 0, 1 and 0, negative 1, which is the same as having 1 over 0 or 1 over negative 0. Now we know that for cotangent, our identity is cosine over sine of theta. So now we have to worry in order to find our isotopes, it's wherever sine is equal to 0. So it would give us 1 or 0 equal undefined. So it's wherever y equals 0. And this only happens at 0 degrees and at 180 degrees, which is the ordered pair of 1, 0 or negative 1, 0, which is the same as having 1 over 0 or 1 over negative 0. So now if we were to do a graph, this would be our graph. Over here we would have 0, over here we would have pi over 2, over here we would have pi, 3 pi over 2, and finally 2 pi. Remember, this is our first quadrant, second, third, and fourth. Okay, so now we were to graph tangent. We know that tangent would start at 0 because at 0 we have the ordered pair of 1, 0, and since we know that it's sine over cosine, we have 0. So it would start at 0. And also have to remember where our isotopes are located at. And we said that it was at 90 and at 270 degrees, which is the same as pi over 2 and 3 pi over 2, which is the same as 90 and 270 degrees. So we said that our tangent graph would start at 0 and it would go up because it's undefined. So it would go up to infinity. It never stops, never touches the isotope. And then again we would start at pi over 2, and from here it would actually start coming down from here because it's 0. And it would come down, and from 0 it would go back up. And again, here it would start from here and go down. As we can see, this is quadrant 1 where tangent is positive. This is quadrant 2 where it's negative. Quadrant 3 where it's positive again, and quadrant 4 where it's negative. Now if we were to do cotangent, we know that our isotopes are located at 0 and 180 degrees. So we do our isotopes. But this time we know that it comes down from here because this is where our isotopes is at, and it stops right here. Because pi over 2 is the same as 0 over 1, which thus gives us 0 over 1 equals to 0, so it means it stops at 0. And from here, it goes all the way like this and goes back down. And then again, then from here, it goes down, stops here, and it goes down. And once again, if we look at cotangent graph, on quadrant 1 it is positive, at quadrant 2 it is negative, at quadrant 3 it is positive, and at quadrant 4 it's negative again. And this is why tangent is uphill and cotangent is downhill.